Hello, Honors Algebra students. Mr. Lawrence here, and we're ready for our first lesson of the fourth quarter. Can you believe it's the fourth quarter already? I know many of you need to take a deep breath. Don't worry, in a couple days we'll be able to. Spring break is coming up very quick. All right, got to do a little bit more work the next couple of days, but then we're going to be okay. All right, today's lesson is going to be about graphing rational expressions. Hopefully at the end you'll be able to say I can graph rational expressions. I can tell you that on Monday you can expect one example from Miss Eubank and then the formative assessment. And if you're good to go, we'll get that homework done and you can enjoy your Monday after school. I hear it's going to be a balmy 40 degrees with snow. But anyway, let's get down to it. Now, take a look at this equation here, y equals 1 over x. Now, do you think this is what? Take a guess. What shape do you think this is going to produce? You know, it might produce a line, a parabola. What do you think is going to happen? Well, it can't be linear. Some of you are thinking it's linear because you see the highest exponent is 1, but I'm going to tell you that the exponent there is really not a 1. Where did, oh, there we go. I could rewrite this, right? Couldn't I rewrite it as y equals x to the negative first power, right? Isn't 1 over x the same as x to the negative first power? So you see the exponent is not actually 1, it's negative 1. So this will not be a linear situation. Now it's not going to be quadratic, it's not going to produce a parabola because it's not squared, right? The highest power is not 2. So I'll tell you what we're going to do. We're going to make a little t-table here, and we're going to plug in values for x and get out values for y. I don't know why, maybe because the computer is on a slant, I cannot draw a vertical line on the airliner. So who says I have to? Look at that, even my line I'm making there was messed up. And I'm going to put a whole bunch of points in right now because I'm trying to figure out what's going to happen here. Once I get a little bit better at this, I won't have to put in so many points. All right, and I'll tell you what, I want to put in, let's see, let's go with 3 negatives, -3, -2, -1. Let's go with 0, 1, 2, and 3, and see if we can see what's going to happen here. All right, so if I put 1 over -3, I get -1/3, and I'm going to graph that 3, 1, 2, 3, and then -1/3 would be like there. I guess I got to spread this out better. I apologize. All right, -2, look at me, a -1/2, right? 1/2. -1 is going to get me -1. I'm curious now because what's going to happen? Um, I'm not really sure what's going to happen here. So I'll tell you what, I'm actually going to put in -1/2. And if I do 1 over -1/2, isn't that the same as -2? So it looks like all of a sudden it's going to climb downward. What if I did like -1/8? Well, 1 over -1/8, wouldn't that be -8? So when I get -8, I'm going to shoot way down here. Okay. What's actually going to happen on the left side of this graph is I'm going to see how good I can do this. Ooh, on the airliner, this is tricky. Hold on a second, ladies and gentlemen. I should really install my graphing calculator on there and show you that way. But let me see here. I am going to get a curve that does something like this. Okay? That's what's going to happen when x is negative. What's going to happen when x is positive? Well, let's see. What's going to happen when x is 0? Some of you already know. Chose the wrong one there. Sorry about that. Doesn't really matter in the scheme of what I'm doing. Here, I'll do these positive ones in blue. And I'll tell you what, I'll go with 3, 2, 1, and I'll even put 0 in. And then I might have to put a couple extra points like I did, but let's see what happens. Okay, let's start with 3. If I put 3 in, I'm going to get 1/3. 2 is going to give me 1/2. 1 is going to give me 1. So 1 is 1. 2 is 1/2. 3 is 1/3. Looks like it's going to come down here and hug the x-axis. 0. What's 1 over 0? And those of you that want to say 0, please have mom boil some pasta and then smack yourself on the wrist with it. This is undefined. You cannot have 1 divided by 0. Undefined. All right, undefined. So we can't do a point there. Let's pick a point in between 1 and 0. Let's take 1/2. 1 over 1/2 is 2. Oh, this is going to climb. If I did 1/8, 1/8 is going to get me an answer of 8. So it's going to come up here and get me an 8. And so this graph here is going to, this part of the graph, I should say, is going to do something like this. And then it's going to come down and hug the x-axis. It's never going to touch. And there's actually 2 asymptotes. Remember we talked about asymptotes? It's been a little while, but there's 2 asymptotes. We know right off the bat that x cannot equal 0 because we can't put 0 in for x, right? That means there's an asymptote there. That's our vertical asymptote. And actually, I'm looking for my line. Sorry. Here we go. Let's do it in purple or magenta. There's a vertical asymptote here. And the equation of the vertical asymptote occurs at x equals 0. That's the equation of that magenta line. There's actually another asymptote, which I'm going to point out. You're not actually going to have to find the equation of it. Some of you will know, but this one is the x-axis. There's a horizontal asymptote there. You'll find that more in Algebra 2, and the equation of that is y equals 0. Okay, and there's your graph. Now, we're going to use t-tables to generate these. We're not going to have to take as long to do it on every problem. But the important things are going to be, 1, to find restrictions. Find restrictions. And what do I mean by restrictions? Well, in this problem, the restriction was x cannot be 0. So in this case, it's x does not equal 0. And there's going to be an asymptote wherever there's a restriction, a vertical asymptote, okay? Hold on a second. My cord's getting caught on my ankle. Not good. Okay. And then I'm going to generate a t-table. All right. So I'm going to generate a t-table. I actually have to do more points, more x values than I'm used to doing, but so I can get the shape of the curve. And I'm going to choose x's on both sides of the vertical asymptote. Okay, so let's look at 2 more examples, and then we're going to do 1 more restriction. Okay, so the first thing I'm going to do here is I'm going to look, and I'm going to see what makes the denominator 0. Whatever number makes the denominator 0, that will be my restriction. So I'm going to add 2 to each side. I'm going to x equals 2. So I have an asymptote occurring at x equals 2. And so I'm going to put that in. I know that my graph vertically is going to hug that. It will not, you know, I don't know where all the points are necessarily without going to a t-table, but I do know it's going to hug that. So let me see here. Let me put in x and y. And with 2, I think I'm going to go with, say, -1, 0, 1. 2 can't happen, and I'm going to go 3, and then I'm going to go 4 and 5, and then I'm going to do a couple more just kind of in my head. So if I put -1 in for x, I'm going to get -1/3. So at -1, I'm going to get -1/3 right there. Okay, sorry about that. When I put 0 in, 1 over 0 minus 2 is going to be -1/2. Strange. I thought I was in right mode. -1/2. So at 0, I'm going to get -1/2. And at 1, I'm going to get a -1, right? Okay. Now, just to do another one, I'm going to consider what's going to happen at, say, -5. Well, when x is -5, I'm going to get -1/7. So 2, 3, 4, 5, 6, 7. Okay. And we're going to end up with something very similar to what we had last time. It's just going to be shifted over. something like that. Okay. Now, of course, this will never go vertical, and it'll never cave back in. It'll get closer and closer and closer to that asymptote. All right, so if I put a 3 in now, going back to my t-table, I get a 1 out. So I get a 1. If I put a 4 in, I get 1/2, and a 5 is going to give me 1/3. So 1/2, and then 1/3. If I put, say, 3.5 in, well, I'm going to get 1/3.5 minus 2, which is the same as 1/1.5, but I don't like the decimal. I'm going to think about 1/2 as 3/2, and, oh, I think I have a mistake. Hold on one second. I didn't actually have a mistake. I wanted to put in 2.5, not 3.5. I apologize for that, because 3.5 wasn't going to show you much. I didn't make any mistake there, but let's put 2.5 in. Oop, wrong equation, silly Mr. Lawrence. Let's put 2.5 in. And when I put 2.5 in for x, okay, I'm going to get 1/2. And 1/1/2 is going to be 2. So at 2.5, we're going to start to shoot up to 2, and then you can kind of see what's going on here. So it's going to do this and this. And now you may be wondering why, how do I know it's not going to cross the x-axis? Well, can you think of any positive number x that you can put into this equation that will get you a negative y out? I can't either. If x is bigger than 2, 2.01, I'm going to get a positive in my denominator. Positive divided by positive is positive. And then if I use any number larger, it's going to continue to stay positive. Same thing is true with the negative side. Any number smaller than 2 is going to generate a negative answer. So our graph will look like that. Okay, here's another example of the graph. I'm going to find my restriction. If you're not sure, if you can't tell, you take 3x plus 4 and you set it equal to 0. I'm going to solve for x and divide by 3. And x is going to equal -1 1/3. So my asymptote is going to be at the equation x equals -1 1/3. So there's -1 1/3 is going to be something like that, and that's really thick and bulky. I'm going to make it a little bit smaller. A little thinner, that is. There we go. I like that a lot better. Okay, so put that at approximately 1/3, maybe about there. And then I'm going to go ahead and generate a t-table. All right, so I'm going to do x and y, and I'm going to pick, say, 3 numbers to the left of my asymptote, which looks like I'm going to want to do -2, -3, and -4. And then I'm going to pick 3 numbers to the right of my asymptote, which looks like I can go with, say, -1, 0, and 1. Okay. So when I put -2 in, I get -6 plus 4 is -2, so that'll be -1/2. So -2, -1/2. -3 will be -9 plus 4, -5, 1/5, -1/5. You see why I want you to be so good at fractions? Okay. -4 is actually, I'm not even going to do it. I know it's going to go up here. And I know by the nature that it's going to shoot down. So my t-table is going to be good for the left side. And it's going to do something. Oops, don't want to turn 90 degrees. Something like that. Okay, if I need to be more precise, I can. I'll use a graphing calculator, or I can do more math, but for our purposes, this suits us very well. Okay, I put -1 in. I'm going to get 3 times -1 is -3, plus 4 is 1, so I'm going to get 1 out. -1 is going to get me 1. If I put 0 in, I'm going to get 1/4. Oh, I knew what bothered me there. Sorry about that. -1 is at 1, and then 0 is at 1/4. Okay, if I put 1 in, I get 3 plus 4 is 7, 1/7. And that is going to be down here. And so the other part of my graph is going to do something like this. And there we go. All right, now, one more example, but we're not actually going to graph it. We're just going to state the restrictions. Now, this looks like something that can be factored, right? Go ahead and factor it. It's going to be the same as 1 over x plus 2 times the quantity of n over x, times the quantity of x minus 2. So this problem is going to have two restrictions. X plus 2 equals 0, subtract 2. X negative 2 is a restriction. And then when I solve this one, I'm going to get x equals 2. So if the restrictions are x cannot equal plus or minus 2. We're not actually going to graph something like that, but it would have two asymptotes. How did I know to do that? I recognize that this expression could be factored, right? Why are they restrictions? Because if I put these numbers in for x into the equation, I get 0 in my denominator. Am I ever allowed to have a denominator of 0? No. All right, that's the video for this weekend. Have a good night, everybody.